here we want to determine all intervals of concavity, all local extrema, along with the inflection points for f of x equals x to the fourth. Well, I'm going to do what I always do. First thing I will do is take a first derivative. So f prime of x equals 4x cubed. Set this equal to 0, and you see that the only critical value is, in fact, when x is equal to 0. Now, I'm looking for inflection points, so I want to take the second derivative. The second derivative is going to be 12x squared. And again, where is this equal to 0? This only happens, once again, when x equals 0. So what we have is 0 as a critical value for the first derivative and also as a candidate for an inflection point based on the second derivative. Now notice here that f double prime of x is in fact greater than 0 for all x, period. That means that f of x is concave up everywhere. Also, since the second derivative does not change signs at 0, it's positive everywhere, then we don't have an inflection point. So there is no change in concavity. Well, yeah, that's what we just got done saying. It's concave up everywhere. So now I need to see if the critical value of x equals 0 is actually identified some type of a local extrema. So notice that f double prime of 0 is equal to 0. Therefore, I need a different test. Since the second derivative is 0, I can't tell if 0 is going to be a local min or a local max based on the second derivative test. I need to go back and take a look at the first derivative at 0, actually each side of 0, and figure out what's going on. So if I look at -1, if I go to the first derivative, f prime of -1 is in fact negative. And then if I look at +1, f prime of +1 is in fact positive. So my first derivative is going from negative to positive. Therefore, I have a local min at x equals 0. Now, you probably already knew that as soon as you saw this function. But it's just kind of nice to work through all the mechanics that we've been dealing with on a function that we know what the result's going to be. It kind of helps solidify our thought process. Because right away, you should have recognized, I'm sure you did recognize the fact that f of x equals x to the fourth is a parabola. It looks like this. So here's my min, just like I advertised. Right there's the min. That's what we just found when x equals 0. It's always concave up, and there are no inflection points.